This is lesson 25, the slope of a line. So if we're doing this, this is our warm-up. Graph the equation by finding the x and y intercepts. So our x-intercept is 6x plus 2, and all along our x-axis our y value is 0, so we're substituting in a 0 for y, so we get 6x equals 12. We divide by 6 and we get x equals 2. So we've got an x-intercept at 2, that's the point 2, 0. Our x value is 2, our y value is 0. To find our y-intercept, now we're going to substitute in a 0 for x, because all numbers along the y-axis, all our x values, x isn't gone, x moves us left or right, and we're not moving left or right, we're just moving up and down, so all our x values are 0. So this leaves us with 2y equals 12. We divide by 2, and we have our y-intercept being 6. That's the point 0, 6. So we can plot that point, and we draw our line between our 2 points, and we've got a nice graph. Homework questions we'll do in class. Today we're going over lesson 25, the slope of a line. So we want to figure out what slope is and where would we find slope in real life. So where do we find slope? Slope can be in anything where it relates the change in one value over the change in another value. So what is slope? Slope for math is going to be change. This delta symbol, the triangle, is change in y. It means change. So change in y over change in x. So that means where what is our change in our y? So if we just pick 2 points here, and I'll just say this point here is -4, 1. -4, 1. And let's pick another point over here. That is 2, 4. 2, 4. And so slope is relating the change in our y value to the change in our x value. So our y values here, our y values, and when we do this we always move from left to right. Okay, I always move from left to right when I do this. So my y value is 1, and we're going to go to 4. So how far is it from 1 to 4? Well, that's a change of 3. And we could also look and say, well, what is y? Y moves us up and down, so we can say we moved up 1, 2, 3 units. From 1 to get to 4, we go up 1, 2, 3 units. So that's where a 3 comes from as well. Now we need to say how far do we move left or right. In this instance, we're moving to the right, and we're moving to the right, well, from -4 to 2, that's 6 units. 1, 2, 3, 4, 5, 6. So our change in x is 6. Now we can simplify that. 3 and 6, 3 goes into both of those, so that simplifies to 1/2. And we can see if we follow this that our y values move up and down, so we're going to go up 1, and our x values move left and right, so because they're both positive we're going to go up and right, so we're going to go up 1 and right 2. Up 1, right 2, we could put in another little point. Up 1 and right 2, put in another point, and up 1 and right 2, and there's back to our original point. We could continue this on, up 1 and right 2, and you'd see that we'd stay being a straight line. We can move the other direction down 1 and left 2. Now let's talk about moving down 1 and left 2. If I moved down 1, that would be negative 1, and left 2, that would be negative 2. Well, what do two negatives make? A negative divided by a negative makes a positive, so we go right back to where we were. So moving down 1 and left 2 is really the same as moving up 1 and right 2. So down 1 and left 2, down 1 and left 2, and we're staying on that line. We make a straight line when we do that. Where would we find examples of slope in real life? So think about that for a second. Have you ever been on a road and it says like a percentage grade of your road? That's a slope. Your stairs are on a slope. They've got to go up and then over and up and over and up and over. That's a slope to your stairs. People don't make, when we make our stairs, you can't make them too steep, right, to be a code at your house, and there has to be a certain rise for every run that you have in order to be on code as well. So stairs have a slope. Everything has a slope. Even what about a table? We'll talk about the slope of a table here in a little bit, but the slope of a table has a special slope to it. So examples of slope. Now think of it as always moving from left to right. So we're going to move from left to right, and if we go up as we move from left to right, we say that's a positive slope. And as we move from left to right, if we go down as we move to left to right, we say that's a negative slope. So we've got a positive slope and a negative slope. If our line goes straight up and down, then we say that we're going to be an undefined slope. Now here's why we're undefined. If I pick a point here, so this point is negative 8, 6, negative 8, 6, and we pick another point here, it's negative 8 over 1. Right, and we say our slope is change in y over change in x. Well, what are my y's changing? From 1 to get to 6, I'm going up 5. You can count it 1, 2, 3, 4, 5. So we're going up 5. But our change in x, negative 8 divided by, the difference from negative 8 to negative 8, we're not moving anything left or right. So that's 0. And anytime we divide by 0, it's undefined. So vertical lines, that's what this is, a line that goes straight up and down, have undefined slope. We're dividing by 0, so that makes it an undefined slope. And people get that confused with a 0 slope. If I picked a point here, this point would be negative 4, 3, negative 4, 3. And I can pick a point, here. This point would be 6, 3. And we're going to do change in y over change in x. Well, what are our y's changing? I'm going from 3 to 3. What kind of change is that? That's a 0 change. And negative 4 to 6, well, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But 0 divided by anything is 0. So horizontal lines have a 0 slope. So we talked about the slope of our table. What kind of slope would a table have? The tabletop would have a 0 slope. The legs going up and down would have an undefined slope of the table. So plotting some points, and then see if we can determine what the slope is. See if we can say if it's positive, negative, 0, undefined. So let's plot A. We'll do that in red. 2, 8. So 2, 8 right here to negative 7, negative 4. Negative 7, negative 4 right here. And we can see that we're rising. We're going up from left to right. And so what is that from left to right? This would be a positive slope. Positive slope. Our next one, negative 5, 9. Negative 5, 9. Right here. To 7, negative 2. To 7, negative 2. Right here. Well, we're going down from left to right, so we're going to say this is a negative slope. Negative slope. Negative 8, negative 4. Negative 8, negative 4 right here. To 6, negative 4. 6, negative 4. Well, that makes a horizontal line. And so all horizontal lines have 0 for a slope. 0. Now notice, all horizontal lines, what do they have the same? Their y values are the same. So if you see two y values that are the same, you know that you're going to have a 0 slope. Our last one, 5, negative 7. 5, negative 7. Right here. And 5, 6. 5, 6. Right here. Well, that will make a vertical line. And we said vertical lines have what kind of slope? They've got an undefined slope. So I'll just say UND for undefined. And notice here, what do they have the same? These blue points have their x values are the same. So something to remember, when we have the same x value, our slope is undefined. When we have the same y value, our slope is 0. It's the difference between having a vertical line or a horizontal line. Example 3, finding the slope of a line from a graph. So let's pick these points. This point here is negative 2, negative 4, negative 2, negative 4. And this point here is 1, 1, 1, 1. And when I do this, I always go from left to right. So, and I do change in y over change in x. What's my y values change? So from negative 4 to get to 1, and I have this number line up here, and you can think about this in your head as well, but here's visually, from negative 4 to get to 1, negative 4 to go to 1, we're going to move 1, 2, 3, 4, 5 units. Our change in y is 5. We can count that as well on the graph. Up 1, 2, 3, 4, 5 units. That's where the 5 comes from. Our change in x, from negative 2 to go to 1, so from negative 2 to get to 1 is 1, 2, 3 units. And we can count that 1, 2, 3 units. So we're going up 1, 2, 3, 4, 5 over 1, 2, 3. So that's 5 over 3. We also call slope, we'll say rise over run. Meaning, how much am I going up compared to how much am I going over? How much am I going up to how much am I going over? If we're moving down, we'd go down and over for a negative slope. You'd also see a fancy equation that's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And so when I do this, I always say that these are my 1s. My 1s on my left are my 1s, my sub 1s, and my points on my right are my sub 2s. So we're going to take the second y value, which was this y value over here, and we're going to say, so it's 1 minus the first y sub 1, the first y value, so minus a negative 4, so minus negative 4. And that's going to be over our second x value, which was this one, 1 minus our first x value, x sub 1, which is our first x value, so minus a negative 2. And so when we say 1 minus a negative 4, that's really 1 plus 4. What is 1 plus 4? That's 5. And 1 minus a negative 2, that's 1 plus 2. So that's 3. So either way you do it, you'll get 5 over 3. I like thinking about it as a change, but really it's the same thing to do y2 minus y1 over x2 minus x1. What else is slope? We also call that the letter m. The letter m will always stand for slope. So you guys try this one. Take a second. The first thing we do is we label our point. So this is negative 7, 4. Negative 7, 4. And this point here is negative 4, negative 5. Negative 4, negative 5. And I do change in y over change in x. So our change in y going from left to right, if we started at 4 and we went to negative 5, that's moving 9 units. Okay, and we're moving down 9 units. You can see graphically from left to right we're moving down. So I say 1, 2, 3, 4, 5, 6, 7, 8, 9. That's down 9. And our change in x from negative 7 to go to negative 4, well here we're moving to the right, so that's positive. Negative 7 to negative 4 is going right 3 units. 1, 2, 3. So what is negative 9 divided by 3? Well, that's the same as negative 3 over 1. And how would we move? If our slope was negative 3 over 1, we'd go down 3, right 1. Watch what happens when we do this. Down 3, 1, 2, 3, right 1. That puts me right on that line again. Down 3, 1, 2, 3, right 1, puts me right on the line again. Down 3, 1, 2, 3, right 1, goes right back to that original point. So negative 9/3 and negative 3 over 1 are equivalent fractions. They're the same slope. We could also say that that slope was just negative 3, and it's assumed that it's over 1, down 3 over 1. So doing a couple of these, finding the slope of the line without the graph, and this is what I do when I just have numbers. Now this way is doing change in y over change in x. So when I do this, I say my change in y, as I just go from my term on my left to my term on my right. And when they're just numbers there, I don't think about which one's on the left or right. I just go from whichever one's written on the left or right. So think of yourself on a number line, and we started at negative 8 right here, and we're going to move all the way over to 6. And here's how a good way to think of it. From negative 8 to get to 0, how far do you have to move? Well, you're moving right 8. And to go from 0 to 6, you're moving right 6. Well, what's 8 plus 6? So that change in y is 8 and 6 makes 14. From negative 8 to positive 6, we're moving 14 units. So now let's do our x values. Our x values, change in x, from negative 5 to get to 7, well, from negative 5 to get over to 7, from negative 5 to 0, I'm going to go 5 units. And from 0 to 7, I'm going to go 7 units, so that's 12 units. We can always simplify this. 14 and 12, 2 goes into both of those. 2 goes into 14 7 times, 2 goes into 12 6 times, and we get our change in our slope is 7 over 6, up 7, right 6. Using the y2 minus y1, so again we'd say that these are our x and y1s and x and y2s, our first point and our second point. That's all that means. So this way, doing the exact same numbers, y2 is a 6 minus y1 is a -8, so minus -8. And here's why I don't like doing this, because when you do stuff, it gets two negatives together. And two negatives turn into a positive. What's 6 plus 8? That makes 14. You can do it, it just, I don't like to. And then our next one, x2 minus x1. So what's our x2 is 7 minus x1 is -5, so minus a -5. And two negatives again turn into a positive, so you get over 12. We can simplify that again, and we get 7, 6. We should get the same answer both ways, because it's really doing the same thing. This next one, change in y over change in x. From 9 to get to -3, we're moving down, right, over here at 9, and we're going to -3. Well, 9 to get to 0 is down 9. 3 more would be down 12, so that's down 12. From -8 to get to 5, -8 to get all the way over to 5, well, from -8 to 0, that's 8, and to go to 5, that's 5 more, so that's 13. So this is -12 over 13. Doing it, our y2 is -3, so -3 minus y1 minus 9 over x2, 5 minus x1, a -8, so that's -8. And we get -3 minus 9 is -12, and 5 plus 8 makes 13, and we get the same answer. This has a negative slope on this one, -12 over 13. -12 over 13 means we're going down 12, right 13. Down 12, right 13. So down 12, right 13, you can see that's a negative slope. What do we notice here right off the bat? We notice that our y values are the same. So if our y values are the same, that means we're going to have a horizontal line, so we should get a slope of 0. Let's do it. Change in y over change in x. From -4 to go to -4, I'm not changing at all, so that's 0. From -8 to go to 6, and I should have went the other direction here, sorry. From -4 to get to -4, it doesn't matter. But from -8 to go to 6, we're going up, what is that? 8 to get to 0 plus 6 is 14. Now, 0 divided by anything, we have a slope of 0. Using the y2 minus y1 over x2 minus x1 method. Remember, these are our 1s and these are our 2s just because it's first and second numbers. So -4 minus a -4 over 6 minus a -8. Well, -4 minus a -4, that turns into a plus, so -4 plus 4 makes 0. Same thing here, 6 minus a -8 turns into 6 plus 8, so that turns into 14. And again, that's going to be 0. Our last one, what do we notice here? We've got the same x values. And we know x values, when our x values are the same, we should get an undefined answer. So change in y over change in x. My change in y from -7 to go to 6, we're going up 13. up 13. But my change in x from 5 to go to 5, we're not moving at all, so we're just going 0. So anytime we divide by 0, our answer is undefined. Using the y1 minus, or y2 minus y1 over x2 minus x1, remember this is our first one, our second point. So y2, 6, minus y1 minus a negative 7 over 5 minus 5. 6 minus negative 7 is 6 plus 7, so that's 13. And 5 minus 5 is 0. So either way, we get undefined. You try this one. So I do it the change in y method. So I say change in y over change in x, and we're going to go from 9 to 7. Well, if we went from 9 to 7, we're going left 2, so that's down 2, over change in x from 3 to negative 5. From 3 to negative 5. Well, here we're going left again. 1, 2, 3, 4, 5, 6, 7, 8. That's down 8. So two negatives are going to make a what? Make a positive. And 2 can go into both of those, so that's 2 goes into 2 once, 2 goes into 8 4 times. So my slope is 1/4, meaning I'm going up 1, right 4. Up. So if I had a point, I'd go up 1, right 4. Up 1, right 4. So I know I'm going to have a positive slope. Example 5, find the value of y so that the line passing through the 2 points has the given slope. So we want to end up with a slope of 3. So we can do this the change in y method too. So we're going to say our change in y over our change in x, and that should equal 3. So let's figure this out. They don't give us another y, so we're going to say from 4 to get to 5, what is my change in x? Well, that's a change of 1, right? And then this is from y to get to 3, and I want this to equal 3. So I want this to equal 3 over 1, or 3. So what does this change need to be? This change in y needs to be a 3 to make it equal 3, right? So what number in here would I go from to get to 3 that would be a 3 change? So I'm 1, 2, 3. I'm going to end up getting to 3. So what number would that be? 1, 2, 3. Well, that's 0. 0, 1, 2, 3. So this y value would have to be 0. This would have to be the point 4, 0. So you guys try this one. We want to get a slope of negative 4 here. Change in y over change in x. And we want this to be negative 4. So we've got our x values. My x value is from 1 to 10. What is that change? That is 9, right? And now from 5 to some number, that needs to be, that I need to be moving negatively because I need to get an answer of negative 4. So another way of this is saying is, what number divided by 9 equals negative 4? Well, here's what you could do as well. Just multiply 9 times negative 4. What's 9 times negative 4? Negative what? Negative 36. So this change And our y values needs to be down 36. So what is 5 minus 36? 5 minus 36 is negative 31. So this y value right here is going to be negative 31. Five to negative 31 is negative 36. Our homework today is homework 25.